So this video is a summary of chapter 4 and all of the big ideas. So the very first thing we looked at in this chapter is learning about radians and then converting degrees to radians and radians to degrees. So the big idea here is 180 degrees is exactly the same as pi radians. And another thing that's pretty important was how do you find the angle in radians? The angle in radians is defined as the ratio of the arc length to the radius of the circle. So you can do some application questions with that idea. So if I have a girl on a swing, and if I tell you the length of the chain and the angle that's made when she swings, you can solve for what is the distance she covers when she swings at the playground. Something else that is pretty common is angular velocity. So you should be able to go from radians per second to degrees per second to revolutions per second. So all of those are basically telling you what is the angular velocity. So you can do some conversion of units to go from one to another. The next big idea, the next lesson, I guess, in this unit is going from angles to ratios and ratios to angles. So if I give you cos theta equals negative root 3 over 2 and theta is between 0 and 2 pi, basically what you have here is I gave you the ratio. Your job is to spit out the angle. You can draw some diagrams, but ultimately I just want the two angles. So the ratio here is negative, and I'm working with cosine, so we're looking at quadrant 2 and quadrant 3. Root 3 over 2 means the reference angle is pi over 6. So pi minus pi over 6 and pi plus pi over 6. So pi minus pi over 6 will be 5 pi over 6. Pi plus pi over 6 will be 7 pi over 6. Cos of 2 pi over 3. So here I give you the angle and your job is to give me the ratio. So second quadrant means it's negative, and then the ratio would be 1/2 because the reference angle is 1 pi over 3. Another common question is if I give you one of the ratios, so for example, if I give you sine theta equals 2/3 and I give you the location of the angle, then you should be able to solve for the other 5 ratios. The cosine ratio, the tan ratio, secant ratio, cosecant ratio, and cotan ratio. Now, the good news is that this part of the unit should be very, very straightforward because this is exactly the same trigonometry that you learned in grade 11. So nothing here in terms of the logic is really new. The only thing that's new is just expressing the angles in radians, but that shouldn't be too difficult. Okay. The next lesson was on equivalent trig expressions. So just building equivalent expressions, but they're trigonometric ones. So we first explored the idea of equivalent trig expressions, expressions that look different but are ultimately mathematically the same. So I've drawn theta is our principal angle, alpha is the reference angle of theta, and beta is complementary to alpha. Okay, so if theta lies in second quadrant, cos theta, I can push it into a first quadrant. Okay, and I won't change it to the complementary trig function. So hopefully what I write here makes sense. Cos theta is equal to minus cos of alpha. Okay, you see it's cosine. I didn't switch it to sine, the complementary trig function, because I'm using the reference angle of theta, which is alpha. Now, what if I wanted to use beta instead? Well, if I use the complementary angle to alpha, it's going to be sine beta. Now minus though, because cosine is negative in the second quadrant. So in both cases, you're pushing it to the first quadrant because alpha and beta are both acute. So you push it to the first quadrant, no problem. But if you use alpha, which is the reference angle of theta, you do not switch the trig function. But if you use beta, which is complementary to alpha, complementary to the reference angle of theta, then you go from cosine to sine. You switch it to the complementary trig function. So you can draw more diagrams and make theta in the third quadrant or the fourth quadrant, but ultimately you're pushing it to the first quadrant and you ask yourself, do I need to switch to the complementary trig function? Which angle am I using? Am I using the reference angle or the angle which is complementary to the reference angle? Okay, then we did, let's see, we did compound angle formulas, and then from there we did double angle formulas, and from double angle formulas you can generate the half angle formulas. To be honest with you, the most important ones are the compound angle and double angle formulas. We won't stress too much on the half angle formulas. That was just a bonus. So compound angle formulas, you have to memorize all of them. I won't go over them all. I'll go over all of them, but you have to memorize the addition and subtraction formula for sine, cos, and tan. And of course, the double angle formula for sine, cos, and tan. Be careful, for cosine there are 3 different versions. So once you learned the compound angle formulas, we applied them. So what can you do with the compound angle formulas? These are 2 very common questions we can put on a test. So something like sine 11 pi over 12. 11 pi over 12 is not our friend because we work with special angles, so the denominators were 3, 4, and 6. Well, 12 is not 3, 4, or 6. So what you do is break apart 11 pi over 12. So 11, how about 8 and 3? 8 and 3 sounds like a good idea because 8 pi over 12, if you do that, that's 2 pi over 3, and that's pi over 4. Now, it's a sum of 2 angles with denominators of 3 and 4, so you can just use the addition formula for sine and then find the ratios and simplify and you're done. Okay, so that's one very common question that we can ask to apply your knowledge of the compound angle formulas. Another question is, if I give you sine A and cos B and ask you what sine of A minus B is. So I'll do one step and then you can do the rest later. So sine A cos B minus sine B cos A. So I have sine A, I have cos B, but I don't know sine B and cos A. But using your grade 11 trig, you should be able to find out what sine B and cos A is. That's essentially what I asked earlier. If I give you one of the trig ratios, you should be able to solve for the other trig ratios as long as you know where the angle is located, which I certainly did provide. I said angle A is in quadrant 2, and I said B is in quadrant 4. Okay? So you should be able to figure out the 4 ratios and then simplify and you're done. Okay, so what's the last topic of this unit? The last topic of this unit is our best friend, identities, trig identities. So we did lots of practice on trig identities. If you did all the homework, you should be pretty fluent when it comes to proving trig identities. The number 1 rule to proving identities is memorizing the trig identities. If you don't have them memorized, you'll have a very hard time being creative. So I highly recommend you to memorize trig identities. And the second rule is don't make up stuff. Follow the algebraic reasoning that you developed in grade 9, 10, 11. Don't abandon that. I know sometimes it's stressful in a test, but don't abandon logic because you'll certainly get the wrong answer that way. Okay, so that's basically all of chapter 4.